Very good morning, everyone. Do let me know. Can you hear me, everyone? Am I audible to each and everyone? Do let me know in the chat section that am I audible to each and everyone? Show me the green signal if you can hear me, kids. I want to see your green signal that if am I audible to each and everyone. So today we are going to start with kids. I want to see your yes. Now, am I audible as well as visible, kids? Do let me know, everyone. So today we are going to start with the most important chapter, that is none other than ArSN2. This ArSN2 is really very important. Before I start, let me tell you, if I say old NCERT, in old NCERT, it is given on page number 303. It is given on page number 303. In old NCERT, it is given on page number 303. Total 3 reactions are given over there on page number 303. 3 reactions, and 304, 1 reaction. Total 4 reactions along with mechanism given over there. If I talk about new NCERT, so the difference in between old NCERT and new NCERT is of 8. So just add 8 to that, you will get 311 and 312 page. Now, first of all, let me welcome each and everyone, my dear students. Just give me a second. I cannot see the chats. Let me see the chats. Where the chats have gone, kids. I'm unable to see the chats. Just give me a second so that I can see where the chat has gone. Just a second, kids. Yeah, now visible. Now they are visible. Yeah, now perfect. Good morning, Bedha Janani, Sangeeta, future doctors, Buddha Surya. Hi, welcome to each and everyone, my dear students. So, first of all, I would like to say sorry because I got a little bit late. You can see the chat section was not visible to me. Now, kids, how are you? Do let me know. How is everyone? How is the Josh? So finally, I welcome each and everyone to yours Unacademy NEET English channel. This is your channel only. So everyone hit the like buttons. I want to see everyone hit the like buttons and show me some fire in the chat section that yes, your magical chemistry guru is over here. And those who cannot afford the Avengers batch, they can buy mind map today I'm going to tell you mind map, the power of mind map. If you have heard the name Tanishka Yadav, AIR1, she was studying from other institute, offline coaching. But because of this mind map, she got first rank. Because the questions of organic chemistry, they were really very trashing, or you can say tough, some of the questions. And she has done all those questions perfectly. So this is the power, something better to say, the mind maps power. I will give the mind maps over here also. But yes, mind map 15 lecture, the complete organic chemistry, that one chapter is linked with another chapter. So number of chapters, they all are linked. How to do the questions based on conversions, that I will let you know in these mind maps. Kids, I will talk about mind maps later on, but right now, let's start ArSN2. If you're there, once I'm telling you each and everything about ArSN2 reaction, you can check your NCERT also at the last. I will let you know in between when to start NCERT and where to see these reactions. Do let me know in the chat section that is everyone ready? Is everyone ready? Kids, do let me know. I want to see that. Write down yes, ready. Everyone is ready, kids. Write down in the chat section that yes, everyone is ready. Yes, kids. Ready, ready, ready. Say ready. Is everyone ready? So, ArSN2 reaction, what does it mean? See, kids. ArSN2 reactions are very, very rare reactions. Very, very. What is the full form ArSN2? Let me tell you first of all. ArSN2 means aromatic SN2 reaction. SN2, you know, second order, which follows second order chemical kinetics. Aromatic bimolecular nucleophilic substitution reaction, or simply I can write aromatic SN2 reaction. Now let me make it one thing very clear. These aromatic SN2 reaction are neither SN2 nor SN1. That is the very, very important point. Sir, what you're talking about? These are neither SN2 nor SN1. Yes, neither. These are neither SN2 nor SN1. This is the real point, kids. Neither SN2 nor SN1. Then what do you mean by aromatic SN2 reaction, sir? What does it mean? I will let you know. But first of all, let me tell you, these reactions are very, very rare. Very, very rare reactions. Now see why these reactions are very, very rare. Because these reactions take place only with aryl halide. You know aryl halide, kids? Aryl halides. Aryl halides. Only with aryl halides. Aryl halide means halobenzene. Now, if something is halobenzene, then what's the problem is over there, kids? In case of halobenzenes, this lone pair is doing resonance with benzene, and that's why this bond, which is looking like single bond, it's not single bond, it has partial double bond character. Partial double bond character. So this bond is very, very powerful bond. This bond is very, very powerful bond. What does it mean? This bond is powerful bond. This means that its bond length decreases by 8 picometer. No need to learn this value. But yes, on page number 303 in old NCERT, it's clearly written that the bond length decreases. Once the bond length decreases, that means bond strength increases. Now let me tell you one thing clearly, so that in any type of examination, whether the question based on assertion, reasoning or something like that, you can do all the questions. See kids, let me zoom in this structure so that clearly you can understand and clearly you can compare. This is X. Let us suppose this is halogen. This is one compound. Now, on the other hand, if I draw one more compound like this, just see to it, everyone. Try to understand. CH2X. And third compound, let me draw like this, without benzene. No benzene is there. No benzene. So all they are carbon to halogen bond. All three compounds are having carbon to halogen bond. See. Now all the carbon to halogen bonds, they are not same. This single bond, due to its lone pair, is doing resonance with benzene. So I would like to say delta positive and partial double bond character, and delta negative and delta negative is there. The bond is moving like this. So this is having bond order greater than 1, means bond strength is too much. This bond, you can see it's positive charge. This X halogens lone pair cannot do resonance, so these are localized, but this lone pair was delocalized. Are you able to understand, kids? Everyone, are you able to understand? I'm telling you the mystery of organic chemistry. The mystery lying behind organic chemistry, that I'm going to tell you. Buddha Surya, sir, this is not fair, sir. Mind map is for only subscription persons. What we are unable to afford single rupee for that. Don't worry, I will give over here also. Don't worry. But yes, there is a scheduled thing. Punctuality will be there, regularity will be there, but don't worry, I will give mind maps over here also. Just wait and watch. In coming 2 days or 3 days, you will get mind map of organic chemistry, mind map of inorganic chemistry, because Buddha Surya, you believe in me, your teacher. So don't worry, this whole world is like mind-minded. No. Money-minded. No. Money-minded people are there, but yes, this Unacademy channel is going to provide each and everything for free also. So Buddha Surya, I have seen your message. Don't worry. If you are regular over here, mind map, they are going to purchase. That is the punctuality. If you can remain punctual over here, you will get each and everything. Don't worry. Say, I want to see Kartiga, Buddha Surya, if you are able to hear me, this is your HSP Baba and this is your Unacademy platform. So this platform is not money minded. You will get each and everything, but just you have to maintain your perseverance, permanency, regularity, hard work. This is we are in need of. Say thank you. Thank you. Say thank you, kids. Now, let me tell you about these three structures. This is benzene, that is not benzene. Now see, this is localized. Once it is going to leave, this positive charge will do resonance. So this bond order is less than 1. Oh my God, it is looking like single bond, but the single bond has partial ionic character. This single bond has partial double bond character. That single bond is having, oh my God, are you able to understand what I am writing, kids? Do let me know. First of all, do let me know, are you able to understand? Thank you, thank you, thank you. Are you able to understand, or should I decrease my speed? Kids, do let me know, should I decrease? Show me some thumbs up, kids. I've given that much gift, that precious gift, that mind-blowing gift from the channel of Unacademy. So show me some thumbs up, kids. Now, what I said, due to this resonance, this single bond has got partial double bond character. Single bond has developed partial double bond character. Double bond character. And kids, due to this benzyl carbocation is resonance stabilized. Not understand. Okay, let me tell you. Okay, let me tell you slowly. Wait. This is hardcore. This is hi-fi. So this is hi-fi. Let me make it simple. Then we will come to ArSN2 reaction. Don't worry, kid. Don't worry. See, let me make it simple. Don't worry, kid. See, one is this compound. Let me tell you the name of this compound. Just try to see. One compound is this. Its name is halobenzene. What? Halobenzene. Let me make it very simple. Or we can say aryl. This is aromatic aryl halide. Or I can say aryl halide. Aryl halide. See, another compound I will draw. This compound is like this. Just try to understand. Each and everything is very, very important. Then only I can start the reaction. This compound's name is benzyl halide. Can you see the difference? Here halogen is directly attached to the benzene. Here in between benzene and halogen there is sp3 hybridized carbon. You can see clearly this halogen is directly attached to sp2 hybridized carbon. That halogen is attached to sp3 hybridized carbon, and this is known as benzyl halide. Benzyl halide. Why I am going to focus over here, kids? This alone holds a whole lot of weightage. 20% of organic chemistry you can do without knowing anything if you are able to understand what is aryl halide, what is benzyl halide. Now see the third compound. Everyone see the third compound. It is not having benzene. It is having simply like this. And this is simply like this. This is normal halide. It's not benzene. It's normal halide. Or you can say aliphatic halide. Normal, or you can say aliphatic halide. Aliphatic. Now try to see what is the difference. All they are single bond, looking like single bond. Let's focus on this green bond. All they are looking to be single bond. All they are looking to be single bond. Carbon to halogen, they all are looking like single bond, kids. All they are looking like single bond. But how they are looking, it's not exactly true. They have a lot of difference. See, what's the differences there? This bond is very, very strong bond. First, let me write down the data. This bond is very, very strong bond. This bond is very, very strong bond. I will let you know the reason. First, let me tell you this bond is very, very strong bond. This bond is weakest bond. Weakest bond. And this bond is normal bond. Normal bond. Till now, I haven't told you the reason. Till now, I haven't told you the reason. But everyone do let me know which halogen is the best leaving group. All they are monovalent. All they are monovalent. Buddha Surya. First of all, let me know. Believers, everyone let me know which halogen is the best leaving group. If you have this much of data in your brain without having the reason in your brain, I will let you know the reason also. But do let me know if you are able to remember it. Which halogen is the best leaving group? Second one. Very good. This halide is the best leaving group. This is the best leaving group. Now, if you are able to understand this thing, your life will become really fantastic. This halide is best leaving group. This halide is going to be the best leaving group. Best leaving group. Let me write down in short. Good leaving group. Good leaving group. So in shortcut GLG, whenever I'm saying GLG means good living group, good living group. Now do let me know which halide is going to be the poorest living group, poorest living group. If you have this much of data in your brain, do let me know which halide is going to be the poorest living group. I will let you know the reason. This holds a hell lot of weightage. 20% of organic chemistry you can do without any. Nani is saying 1. Everyone is saying 1. Very good. This halogen is going to be the poorest living group. This is going to be the poorest living group. This halide is going to be the poorest living group, right? Poorest living group. Let me write down PLG, Parle-G. It's not Parle-G, it's poorest living group, which is going to be the normal living group. So definitely this is going to be the normal living group. So if we don't know anything, we can say which one can say, just see which one can show the best NSR, easily NSR, which out of these three, which can show the fastest NSR, best NSR, nucleophilic substitution reaction, fastest reaction. If you have this much of data in your brain, do let me know, kids. Everyone do let me know. So this will show fastest nucleophilic substitution reaction, whether that is SN2 or SN1, whatever it is, fastest SN2 reaction. This will show fastest NSR, whether it is SN2 or it is SN1, both, which will show or which will not show SN2, SN1 at normal condition, no NSR at normal condition. Do let me know. Out of these three, which will not show, this is, let us suppose A, this is being B, this is being C, which will not show NSR at normal under ordinary conditions, which will not show NSR under ordinary conditions. Kids, do let me know. C. Your answer is wrong. Buddha Surya, your answer is wrong. See why? Which is poorest living group? This one is the poorest living group. So this will not show NSR under ordinary conditions, Now, kids, till now you must be thinking about, sir, where is the reason? Where the reason has got? Till now, is it clear to all of you? Nani is correct. Nani absolutely correct. Now, let me tell you the reasons. See, everyone, I'm going to tell you the reasons. Why the reasons and what's the reasons are there. See, first of all, let me explain this compound. This compound is having halogen over here, and this compound is having lone pair. Lone pair, can you see? Lone pair means free electrons. Whenever you are having free electrons, the free electrons will move, and this electron will try to come over here, and this electron has to shift over here. Lone pair pi bond conjugation. This is known as lone pair pi bond conjugation. What do you say? Lone pair pi bond conjugation. Lone pair pi bond conjugation. So I have told you, whenever there is lone pair pi bond conjugation, who is going to move? The lone pair will move towards pi bond. This thing is clear. I'm telling you slowly, each and everything. Kids, are you able to get it? I'm here to make you clear this thing. I'm not here for the views like other channels. This channel is meant for teaching you, telling you, understanding you, making you to feel it so that you can get the best rank. Kids, my efforts over here are not less than the that batch, paid batch, right? Same efforts I'm putting over here. So see, once it is coming over here, it will form resonating structure. It will form resonating structure, and its resonating structure, and better to say resonance hybrid, look like this. This is the resonance hybrid. See, it will form 5 non-equivalent resonating structures, and these 5 non-equivalent resonating structures will be like this. And see, this was the single bond, and here it has developed some character. It's not double bond. It is somewhat in between single and double bond. I cannot say 1.7, 1.3, 1.2, 1.3, 1.4, 1.5. I cannot say. It is having bond of more than 1, less than 2. So what I will say, this bond length is like single bond. This bond length is like single bond or somewhat more powerful than single bond. Do let me know. It is like single bond or somewhat more powerful than single bond. Just like we have fingers, and once, boxers, the boxers, they used to have gloves, right? Then the power gets increased for the fingers or not. So this bond length got decreased, and the NCERT is writing bond length decreased by 8 picometer as compared to pure single bond. As compared to pure single bond. So what do you think? If it is got decreased, then the bond strength increased or not? This bond strength increased or not? Do let me know, kids. Bond strength increased. Bond strength increased. Now, this was the first approach. That's why this is poor leaving group, and this will not leave. And when this is not going to leave, the nucleophile cannot attack easily. Now, by chance if you remove halide, then halide will go by taking electron, and this compound will look like this. See, there is one more approach. It will look like this. What do you think? Is this compound stable or unstable? Kids, is this compound stable or unstable? I want to see in the chat section, is this compound stable or unstable? This plus charge is localized, cannot take part in resonance. This I taught you in GOC. So this compound is highly unstable. When this is highly unstable, that means this reaction can't take place. So one thing is very clear. Whenever halogen is attached to the double bonded carbon, whenever halogen is attached to the sp2 hybridized carbon, then that cannot show reaction easily. This halogen is attached to the double bonded carbon, sp2 hybridized carbon. That means it is the poorest leaving group. So that's why I have told you one day that don't see who is the atom. More important is where is that atom, which is going to be good leaving group. That is okay. What type of atom is present is better to say where it is present. Suppose if I am very powerful, but I am inside the sea, then shark is going to kill me. When the shark is on the land and I am also on the land, definitely shark will die by itself. So shark is very powerful, but powerful only when it is inside the water. Then medium matters a lot. Everyone is able to understand. So this is halobenzene. This was your halobenzene. So whenever halobenzene is given over there, you will say cannot show nucleophilic substitution reaction easily. Now see, if I take benzyl halide, see, if I take benzyl halide. This is your benzyl halide. How to find out benzyl halide? If ever the halogen is attached to the sp3 hybridized carbon which is adjacent to the phenyl, this is phenyl, and if I consider the whole thing, this much is benzyl, this much is benzyl. Can you see the difference between phenyl and benzyl? First of all, everyone see what is phenyl and what is benzyl. If you are having this much is benzyl, this much is benzyl, and if you are having only this much, then this much is phenyl, this much is phenyl. Kids, it can be given like this, or it can be written like this. This can be written like C6H5CH2. It can be written like this also. It can be written like this also. They all are, or it can be written like this also. They all are being benzyl. And this can be written like C6H5. This is phenyl, or it can be written like PH phenyl. So can you find out the difference between phenyl and benzyl? So I was talking about this is benzyl halide. This is benzyl halide. Now if this X is going to leave, how it will look like? It will look like this. The carbon will develop positive charge. Now resonance is there or not? This is doing resonance with the benzene. Now this carbon is saying to this halogen, you want to leave, then go away from my life. Just leave me. I don't require you, because once you are going to leave, I will develop positive charge, and that positive charge will do resonance, and it will get stabilized by resonance. Suppose somebody is in your life. Suppose somebody is in your life, your friend, and always he or she is saying, I will leave you, I will leave you. Now what you will say? If you can't do your homework without that candidate, if you can't do your work without that candidate, you will say, please don't leave me. I will follow whatever you say. But if you are self-sufficient, what you will say? What will be your answer? Oh, if you want to leave, just go right now. I don't need you. And if you can't do your work without that candidate, you will say, I need you, I need you, I need you right now, I need you right now. You will say like that or not? Sir, how to say which one is benzene and which one is phenol? I will let you know which one is benzene. Oh, benzene or phenol, or benzene and phenyl? What do you want to say? You are talking about Buddha Surya, benzene and phenol, or benzene and phenyl? Okay, let me tell you. See, everyone, C6H6, this is benzene. It will look like this. See, it's benzene. This is benzene. Clear to all of you? These are the minute questions, but yes, if you don't know, then they are going to kill. Now, if I remove one hydrogen from this, one hydrogen has been removed, it will become C6H5. This is your phenyl. I hope you are able to understand. Now see, if I write this one is your toluene. Can you see toluene? Can you say? C6H5CH3. This is your toluene. Now if I remove one hydrogen from toluene, what I will have? I will have compound like this. This is your benzyl, C6H5CH2. I hope Buddha Surya it is clear. This is your benzyl. First we have to understand these terminologies. Otherwise we won't be able to understand anything. So these things are clear. First of all, do let me know, then only I can start ArSN2 reaction. If we don't know, if we don't have the knowledge of these things, we won't be able to understand. Now see kids, this is benzyl. Now if I write something like this, this is benzyl, or we can pronunciate it to be benzyl. If I write something like this, we will say this is divalent. We will say benzyl. Everyone say along with me, benzyl. And if I write something like this, then we will say benzo. What is the difference between benzo? One is being monovalent. This is being monovalent, kids. Monovalent. This is being divalent. And this is being trivalent. Everyone say along with me, benzyl. Say benzyl. Everyone, wherever you are sitting, say benzyl, benzo. Say everyone, benzyl, benzo. Vehti Hawa, in the movie 3 Idiot movie, there was Vehti Hawa sa tha wo, yaar hamara tha wo, kahan gaya use dhoondho. So that is the song in 3 Idiots movie. Oh. Benzo. So you should know this is benzyl, that is benzo. Now see kids. Everyone see to it. Finally, I am going to tell you this compound I have written. I wrote this compound. This is your benzyl halide. So name is clear to all of you. Benzyl halide. This is normal halide. And this is your aryl halide. So which is best leaving group? I have changed the order. I have flipped it. So you can see very clearly if somebody is saying arrange them in decreasing order of reaction. So this is the best leaving group. This will show reaction with fastest rate because its single bond has partial ionic character. This is broken bond, broken hearts. You must have heard broken hearts. This is broken bond. Its bond order is less than 1. So the single bond has got partial ionic character. Single bond has developed partial ionic character. Now in shortcut, whenever it is going to come, I will write SB has pick. What is the full form? SB has pick. Single bond has developed partial ionic character. Just try to understand. Single bond has developed partial ionic character. This is normal. So this is good leaving group. This X is good leaving group. This is normal bond. Bond order is 1 exactly. So this is normal leaving group. And this single bond has partial double bond character. SB has partial double bond character. So its bond order is greater than 1. So this is the rate for SN2 SN1, rate of nucleophilic substitution reaction. So this is a brilliant question. Number of times this question has been asked. Now you must be thinking, sir, till now 45 minutes have gone and you have not started ArSN2. You must be thinking like that. Sir, 30 to 45 minutes they have gone and till now you are not able to start ArSN2. Now I am going to start ArSN2 reaction because this was the base. This was the foundation for ArSN2 reaction. This much we should have to have in our brain, then only we can understand ArSN2 reaction. So everyone ready? Is everyone ready, kids? Let's start ArSN2 reaction. First of all, let me write down the reaction. Halobenzene. Halobenzene is going to react with NaOH. Kids, do let me know what should be the product. If I write only this much, what should be the product in the chat section? Everyone write down. What should be the product? Only if this much is written, no reaction. Reaction cannot take place. So what else is required? 623 Kelvin temperature plus 300 atmospheric pressure and H plus, then all the reaction is going to take place. High temperature, high pressure, HTP. HTP means high temperature and pressure is required. Now it is going to form product as phenol. Phenol will be the product. And name of this reaction is Dawes process. Dawes reaction or process, and this reaction takes place in two steps. This is a two-step reaction. What are these two steps? First step is addition and second step is elimination. First is addition and second is being elimination. So are you ready for the mechanism? I'm going to tell you the mechanism for this reaction. So is everyone ready? Hey kids, are you ready? See the mechanism of this reaction. Two-step reactions mechanism, two-step mechanism. Step number one. First step is addition. Now just try to understand what I am going to tell you. This is your halobenzene and this is X. Once OH negative is going to approach it, OH negative is saying, I will attack on this carbon. Is it possible that OH negative can come from the back and attack on this carbon? No. Backside attack is not possible. Why backside attack is not possible? Because you know that these electrons will show repulsion. So this attack is not possible. Attack is not possible. Backside attack is not possible. Backside attack is not possible. That means it cannot show SN2 reaction. This shows no SN2 reaction. Now, if I say this is going to form carbocation, its carbocation is also not stable, so no SN1 reaction. So what is required for this reaction to take place? High temperature is required. When you provide high temperature, kids, you know that by getting heat, molecules come nearer or they go far away. When you provide temperature, these two molecules will go far away. That means with alone the temperature, this reaction is not possible. You supply temperature from the below side and apply pressure from the upper side. Now what is going to happen? If you are applying pressure, molecules cannot go far away, because getting pressure, molecules will come closer, and getting heat, bonds are going to break. But which bond is going to break? This bond is powerful bond. This is very, very powerful bond. So this is not going to break. This pi bond will break, and because of high temperature, there is shifting of this pi bond, and this pi bond will shift toward this side. Now question arises, why only toward this side? Why this pi bond has not shifted toward this side? I will let you know why the shifting was only towards that side only. So because of shifting, it has become like this, it has become like this, and this is x, and there is partial positive charge. Once there is partial positive charge, this x will stabilize this through back bonding. That's why plus charge is over here, not over there. This halogen will stabilize this plus charge through back bonding, and this OH has attacked over here. So in the life of this compound, this OH has got the entry, but this is slowest step. Now people will ask, why sir, why this is going towards more in the backward direction, less in the forward direction? Kids, let me tell you why this is happening. So this is a reversible step, slowest step, and slowest steps are always the rate determining step, RDS. See, this benzene is aromatic. Right now, this is aromatic, so highly stable. This is aromatic, so this is highly stable. And once this is highly stable, this is, you can see this carbon is sp3 hybridized. Although it is having 6 pi electron, students are generally going to see, oh, it is following Huckel's rule, then this is aromatic. No, see kids. First of all, always try to see planarity rule. If the ring is not planar, once the ring is not planar, that the ring can never be aromatic. So this ring is not planar, sp3 hybridized, so not planar. Not a planar ring can never be aromatic, so not aromatic. Not aromatic means unstable, less stable than this compound. So this is less stable. So what do you think? The thing is moving from stable towards unstable. So this is slowest step, rate determining step. And the first time you can see the biggest thing has happened. The intermediate is carbanion. Till now we have seen in SN1 reaction, the intermediate was carbocation. In SN2 reaction, there was no intermediate, but in ArSN2 reaction, the intermediate is being carbanion. So this is something new, that in this reaction, remember, carbanion is the intermediate. This is the point to be noted, my lord. This is really very, very important point. Here in this reaction, carbanion is the intermediate. That is the most important thing. That carbanion is the intermediate. Now see kids, second thing. In SN2 reaction, there was backside attack. In SN1 reaction, there was carbocation. And here in this reaction, there is sidewise attack. Neither front side nor back side. Sidewise attack has taken place. Sidewise attack in ArSN2 reaction, sidewise attack has taken place. That's why in the starting only I have told you that it's neither SN2 reaction nor SN1 reaction. It is ArSN2 reaction. Now see, we have to focus over here, because the rate of this reaction, ArSN2 reaction, is directly proportional to the stability of carbanion. See this carbanion. Let me make this carbanion on the next page so that each and everything is visible to all of you. Oh my God. Priya Paul, you're liking this session. That's why green hearts are coming from that side. You're liking it. You're loving this session. Thank you. Thank you from the inner core of my heart for this liking. Now see, let me show you this carbanion stability. Let's talk about this carbanion stability. This negative charge is over here, and this X is over here, and this nucleophile OH is over here. The interesting points, see, interesting points about this carbanion. Because if we don't know these interesting points, we won't be able to see or feel this chemistry and we will not get the marks. This halogen is still intact with this intermediate. You have seen, we saw in SN1 reaction, in the rate determining step, leaving group was halide. In SN2 reaction, that was single step reaction, simultaneous breaking and making of bond was there, leaving group was halide. In both the two reactions, in SN1 and SN2 reaction, halide was the leaving group, but here the slowest step, leaving group has not gone. It's not like SN1 and SN2, still the halide group is forming a bond with carbon. So this is the very special point about this reaction. So it's very interesting point is that it's not like SN2 and SN1 where the leaving group that was halogen generally were leaving the substrate in rate determining step. So it's not like SN2 and SN1 where the leaving group was leaving the substrate in the rate determining step. Here in this reaction, that is ArSN2, the leaving group is still present over there, Now see kids, what I am telling you, this reaction is directly proportional to the stability of this carbon ion, and this halide is withdrawing the electron. See, halogen is having minus I and it is withdrawing electron towards itself side from this carbon. So just to let me know, when it is withdrawing electron withdrawing group, the negative charge, the magnitude of negative charge will decrease or the magnitude of negative charge will increase. Everyone smash the like buttons if you're liking this session. Just do let me know, this magnitude of negative charge is going to increase or will get decrease in the chat section. Do let me know everyone. The magnitude of negative charge will increase or decrease, kids. Definitely this negative charge magnitude of charge will decrease. Magnitude of charge will decrease. And kids, this intermediate will get more stability. So halides are increasing the stability of intermediate. So carbon ion will stabilize. Now kids, if you are having a little bit knowledge of inductive fact, do let me know which halogen has got maximum minus I effect. Which halogen has got maximum minus I effect? Fluorine, chlorine, bromine, iodine. Do let me know which halogen is having maximum minus I. Everyone, do let me know which halogen has got maximum minus I. So definitely the answer is fluorine. So kids, so first point is minus I effect, because we know that rate of ArSN2 reaction is directly proportional to the stability of carbon ion. So this is the very first time which will show maximum rate of reaction. So fluorobenzene will be most reactive. Sir, what you are talking about? Fluorobenzene? Always you were saying fluorine is not leaving group. Kids, this is the really fantastic thing about ArSN2 reaction. The order got changed, and that's why every student gets failed over here. Kids, in other reactions you have seen iodine was a good leaving group. In SN2 reaction, iodine was good leaving group. In SN1 reaction, iodine was good leaving group. And always iodine was the best leaving group, and that was most reactive. But in this reaction, the order is like this. Rate of reaction is not. What do you think? Is this something miracle? Rate of reaction. Rate of reaction. This is most reactive. Most reactive. Now, how will you define this is most reactive and this is the least reactive? Kids, let me tell you. Iodine, that iodide is best leaving group, but here I have told you, never see the atoms, what is their power. It always depends where are you, who are you is not that important. Where are you, where you are present, that is more important. Earlier iodine was the best leaving group, but in this reaction leaving group tendency has no role in the rate determining step. That is the most important point in this reaction. Leaving group tendency, leaving group tendency has no role in rate of reaction, because leaving group is not leaving in the rate determining step. This is something very special thing, very special. Otherwise students must think, oh, this is wrong order, by chance teacher has written wrong. Kids, it is absolutely correct. Now see the second factor. This was the factor number one. Factor number two. Let's see the factor number two. Is everyone ready to see the factor number two? Factor number two is resonance. Now see, we cannot ignore resonance. This is the most important thing, resonance. Now see what's the role of resonance and how it is going to play its role. See, this was our intermediate. This was X, this was OH. What do you think? This will show resonance or not? This compound will be resonance stabilized or not? Do let me know. Yes, this negative charge will shift over here and this pi bond will come over here. So it will be the resonating structure like this. Once again, this negative charge will shift over here and this pi bond will shift over here. So you can see very clearly these are the three resonating structures, and where you have got the negative charge. So if I draw the resonance hybrid of these compounds, then the actual structure or the resonance hybrid will look like this: negative charge, negative charge, negative charge. This is X and this is OH. Can I write something like that? The negative charge is on OP positions with respect to this halogen, with respect to halogen negative charge is on OP positions. OP positions. Am I right? So, before I move ahead, let me have a sip of water. Let me check it out. What is there or not? Kids, are you enjoying it? Everyone do let me know. Are you able to understand? Vedha Janani, believers, all my dear students, Arthi, you are regular students. That is the most important thing. Once if you are regular, then nothing can stop you to get the best rank. Always say to yourself, you are important. Your hard work, definitely your success, you can see there. Now, kids, you can see this is the actual structure, and I would like to say this is actual resonance hybrid. This is resonance hybrid. So you know that what we want freedom or not. Everyone wants to have freedom or not. Kids, do let me know. We are particle. We as a particle, we want to have freedom. Then just think about electrons. They are having wavical nature, particle as well as wave nature. What these electrons would like to feel? They want freedom or less freedom? Do let me know. If electrons are getting freedom, they will enjoy the freedom, or they are not going to enjoy the freedom. Do let me know. Everyone do let me know. Then only I can move ahead. That electrons being wavical nature, electrons being having wavical nature, wavical, that is particle as well as wave nature, wavical nature, they will enjoy freedom or not? Freedom is important for them or not? More freedom, if they are getting more freedom, more stability, more freedom, more stability. This is the fundamental thing. Just think about Corona time, COVID time. During COVID time, everyone was in their homes only. Government said no need to come outside. Just think about those days, everyone. Just think about those days when the COVID pandemic time was there. Everyone was localized in their home only. No one was allowed to get delocalized to move here and there. Just think about that time. Restriction was there. So we were not feeling good. We were not feeling freedom. So think about electrons. You think about the scent, perfume, when it is inside the bottle, it is not able to spread its aroma. But once that perfume is allowed to move outside that bottle, then it is going to spread its aroma. So that is wavical nature. Now see what I am going to tell you, what I mean. See, kids, this was your compound. This was your compound. And the negative charge was present over here, over here, over here, and it was delocalized. And here was X, here was OH. The negative charge was doing resonance from here to here. This negative charge was doing resonance from this place to this place. Am I right? Only this much was the delocalization of negative charge. But if I place some group like NO2, electron withdrawing group, then what this electron withdrawing group will say, hey, negative charge, come and do resonance on NO2 also, because this is minus M minus R, that is electron withdrawing group. This group will withdraw its electrons towards its side, and this is extra resonance. Extra resonance, kids. This will be extra resonance. Now say, due to extra resonance, this electron will feel good or bad? Extra resonance, extra delocalization. That means it is having extra stability. If I place NO2 group at this position also, then it will have more resonance, more stabilization. Just see where I am placing minus M group. I am placing minus M group at ortho para position, so that it should get extra stabilization. So this compound has become now highly stable because of extra minus M group. So this shows, in case of putting minus M groups at ortho or para or both, the stability will increase. The stability of carbon ion will increase, and the rate of reaction will increase. And that's why now I'm going to show you those 4 reactions which are given in NCERT. See, I'm going to show you the 4 reactions, then you will be able to understand each and everything, kids. See, reaction number 1, reaction number 2, reaction number 3, all 4 reactions I'm going to show you. This is the first reaction I'm going to write. This is the second reaction which I'm going to write. This is the third reaction which I'm going to write. And this is the fourth reaction which I'm going to write. NCERT page number 303. So are you ready, everyone? Are you ready, everyone? Do let me know. Yes, sir, we are ready. See, kids, reaction number 1. This reaction is given in your NCERT that this is your chlorobenzene, and when this is allowed to react with NaOH, how much temperature and pressure is required? Temperature, pressure required is how much? See, they are saying 623 Kelvin temperature and 300 atmospheric pressure is required. 300 atmospheric pressure is required, and H plus, then this is going to form phenol. This is the phenol has been formed, kids. Just try to understand. Now let me show you the second reaction. What is the second reaction they have given? This was the first. Let me tell you the second reaction. They are saying that if one NO2 is attached, do let me know, the rate of reaction will be increase or decrease. Definitely the rate of reaction is going to get increased. Now they are saying that this reaction will take place only at 449 Kelvin, and you will get product only at 449 Kelvin. Just you can see your NCERT, you can check it out. The third reaction, they are saying if you place 2 NO2s, then the rate of reaction will further get increased, and now this reaction is possible just at 368 Kelvin temperature. No pressure is required. You will get the product. See, kids, whether am I right or not. And the fourth reaction, turn over the page, you will see the miracle. If we place 3 NO2s, 1 NO2, second NO2, third NO2, and now simply with water, no need of NaOH, warm water, this reaction is possible. No need of even NaOH. This reaction is very easy, and it will give you picric acid 2,4,6 trinitrophenol 2,4,6 trinitrophenol. This picric acid is highly acidic. It's just check it out. These 4 reactions are given in NCERT or not? Now Once you see these reactions in old NCERT at page number 303, 304, this is all about old NCERT. And if I say in new NCERT, page number 311, 312, this is new NCERT. Now kids, if you are able to understand, do let me know. I am going to give you questions. Try to find out the answer of these questions, and then I will let you know one more mechanism which is not given in NCERT, Cine substitution. That Cine substitution is not given in NCERT, so do not leave the lecture because that is very, very important. Okay, just don't think that ArSN2 got completed. I'm going to tell you Cine substitution. In 2016, they have asked question. Two times the paper was held in that session and they have asked, that was the toughest organic question. Organic chemistry portion was really the toughest at that time. So that is required. That is not mentioned in NCERT, and that's why I say that NCERT writes in between the line. Now see its question. Try to answer the question. Question number 1. Are you ready for the question, kids? Everyone, is everyone ready for the question? Question number 1. Arrange the following in decreasing order for rate of reaction with NaOH H plus. NaOH H plus. Is everyone ready? Now see kids. One compound is A, fluorine, NO2, NO2, NO2. Second compound is chlorine, NO2, NO2. Third compound is bromine, NO2. Fourth compound is iodine, that is iodobenzene. Do let me know. What should be the order for this rate of reaction, kids? Everyone do let me know. If you are able to understand this reaction, kids, everyone do let me know what should be the answer. I'm waiting for your answer, kids. Everyone do let me know. 1, 2, 3, 4. Who has given the answer? Wow, Shanti Prabha, Vedha Janani, fantastic. A, B, C, D is the correct answer. A, B, C, D is the correct answer. Now I will give you tough question, rank deciding question. Are you ready for that? Rank deciding question, kids. This was the normal question. This was the normal question. Now I'm going to give you the rank deciding question. See, rank deciding question. Rank deciding question. Rank deciding question is, one compound you are provided like this: chlorine, fluorine, chlorine, NO2, this is A compound, plus NaOH, H plus. Second compound is given like this: chlorine, fluorine, NO2. Just try, apply your brain. You have to compare the rate of reaction, which is having more rate, which will move fast, gets which reaction will have more rate. This is a really wonderful question. Fantastic question, kids. If you are able to do it, do let me know in the chat section. Let me find out what's your answer. Fantastic question. Which will have more rate? One answer I got, Shanti Prabhas 2. Let me check it out. What other answer other students are going to give? B. Everyone is saying B. Kids, see, your answer is wrong. Let me tell you why your answer is wrong. See, both of you have given the wrong answer. See, I've told you that minus M group should be at orthopara position. You see, with respect to this chlorine, this NO2 is at meta. With respect to chlorine, this is at meta. And with respect to fluorine, this NO2 is at para. So don't see this, see this, that they are just at 180 degree. So this is fluorine at 180 degree at para position. So this fluorine is at para. Now in this, don't see that. You see this 180 degree, this para, chlorine is at para. This chlorine is at para with respect to NO2. So what do you think? Who is going to give more rate? Fluorine is going to give more rate or chlorine is going to give more rate? Kids, do let me know now. Are you able to understand or not? We have to see orthopara. The NO2 group, that is minus M group, must be present at orthopara. So definitely this is having more rate, and its product will be, let me tell you, its product will be, the product of this reaction will be like this. There will be OH, not at chlorine. Chlorine will remain like this only. This will be the product of this reaction, and here the product will be, fluorine will remain over there only. Here will be OH and this is NO2. Are you able to understand? If yes, show me the thumbs up, kids. This is really fantastic reaction. If you are able to understand, do let me know. Yes, sir, we got it. This is really wonderful reaction. Fantastic, awesome reaction, kids. Everyone, do let me know that you are able to understand it or not. I want to see. Now everyone is able to understand, kids. Now, how the scientist has become mad with this reaction. I'm going to show you the reaction. Scientists got shocked. Scientists got shocked when they saw this reaction. See which reaction. See, kids, which reaction they have seen and why they have become shocked. See there, scientists. What is the problem of scientists? Let me show you, kids. See this reaction. You can see the halogen is over there and this is aryl halide. When they have reacted this compound with NaNH2, and why NCERT has not given this reaction, I will let you know. Then the scientists, they saw what they saw, that from where the X is going to leave, the product is formed there. NH2 has attached at the same carbon from where halogen has left. Along with this product, one abnormal product was formed, because this position, from this position halogen has left, at the ortho of that NH2 has formed the bond. This was abnormal reaction. See, kids, what is the something great in this reaction? Abnormal reaction. This halogen is attached with sp2 hybridized carbon. This is being sp2 hybridized carbon. Then also this reaction is taking place at room temperature. And I would like to say this reaction has ability to take place even in negative temperature. This reaction can take place at room temperature or at negative temperature also, or at negative temperature also. This was really a shocking reaction for the scientists, because they were telling that halobenzene, which is attached with phenyl, cannot show reaction without having drastic condition. So this is the revolution in the scientific industry, kids. Now they started searching how this reaction is possible. This was normal product. This was normal product, and the below one was abnormal product. Why abnormal? Because from where the leaving group is going, just at the ortho of that, it is attached abnormal product, and that's why this product is known as ortho product or sine substitution. Ortho product or sine substitution. And kids, let me tell you, this question was asked in 2016, even though it was mentioned in IIT syllabus that sine substitution is not in their syllabus. And this sine substitution no teacher was teaching, so everyone got failed except my students, HSP's students, because I kept on teaching for the last 23 years. As you know that everyone, I've got double degree, double postgraduate degree, MTech as well as MSc. I know very well what to teach, what to tell students, what not to tell. For the last 23 plus years, I have been teaching this reaction, and in 2016, they have asked this reaction. Now kids, this is not following carbanion mechanism. This is also ArSN2, kids. Let me tell you, not given in NCERT. First of all, let me tell you, not given in NCERT, not mentioned even in NCERT. But then also they have asked questions. See how cruel the setting papers are there. The paper setters, how much cruel they are. They are always saying just study NCERT, but they are giving out of NCERT also. So you need a teacher like me so that to get full marks. And this is the year when Mehak Arora and number of other students, they have got AIMS 3rd rank, Chaitanya Mittal 4th rank. Then after the year, it's that time AIMS was taking separate examination and they got best rank in NEET also. Now see kids, this reaction follows two-step mechanism with the benzene formation. Intermediate is benzene. For this reaction, who is the intermediate? And this is the history when benzene was discovered. Benzene was discovered. Benzene is the intermediate, kids. Have you heard the name benzene? Benzene is a special structure. Benzene, it follows two steps mechanism, that is benzene as the intermediate. Is everyone ready to understand this mechanism? It will take just 20 minutes, then the syllabus will get over. Kids, just to let me know, is everyone ready to understand this mechanism? Because this is very, very special reaction, not mentioned in even in NCERT. So this is very, very special reaction. Very, very special reaction. Is everyone agreed? Have you got that much energy? Show me the thumbs up that yes, you are ready. I want to see. Smash the like button. At least make it 50, kids. It's 44. Just hit the like buttons. Make it 50, kids. Now see, I'm going to tell you this mechanism and this reaction. This reaction follows two-step mechanism. This reaction follows two-step mechanism. What is that? Two-step mechanism. Kids, see, two-step mechanism. That first step is elimination, and second step is being addition. So overall we will say it is substitution. If we add these two steps, we will say it is substitution reaction. Now kids, just at the back of this, I've told you first step was addition and then second step was elimination. In that reaction, the carbon ion was the intermediate. In this reaction, benzene is the intermediate, and let's see how the reaction will proceed with benzene. What is benzene? Benzene is the intermediate. This is the special thing about this reaction. Benzyl is the intermediate in this reaction. So this is something really special, benzene. Now let me tell you first step, then I will tell you second step, and that is really the mind-blowing. You won't be able to understand, you won't be able to believe that how is it possible. So stay tuned with me. So try to understand each and everything. See, step number one. Step number one, elimination. Step number one, elimination. See kids, this is your halobenzene, and I will draw some hydrogens. These hydrogens I have drawn with green pen, and other hydrogens I will draw with red pens, red marker, red pen, red stylus. So these green hydrogens are required for this reaction. These are must. These hydrogens, either of this hydrogen ortho, at least one ortho hydrogen is compulsory. At least one ortho hydrogen is compulsory. Otherwise this reaction will not take place. At least one ortho hydrogen is compulsory, otherwise this reaction will not take place. Now see why this ortho hydrogen is compulsory. Whenever the Na plus NH2 negative is going to approach, that NH2 negative is saying, I like this hydrogen. For me, with respect to this NH2 negative, this hydrogen is acidic, or this hydrogen is acidic. Both are same. Now kids, you will say, sir, how is it possible that these hydrogens are acidic? These are arylic hydrogens, and arylic hydrogens are poor leaving groups. These are arylic hydrogens, and arylic hydrogens are poor leaving groups. Then how it is going? The whole chemistry is getting mind-blowing. If you see HSP's chemistry, see kids, with me, chemical compounds, they are going to speak with me. Now see kids, have you ever eaten chicken, mutton? Are you non-vegetarian? Some of you must be vegetarian, some of you must be non-vegetarian. Once if you have eaten chicken, what do you think? Are you able to chew those bones? Are you able to eat those bones of chicken? Is it possible that you can eat the bones, or you are going to throw the bones? Kids, do let me know in the chat section. Are you going to eat the bones, the whole chicken along with the bones, or you are going to throw these bones? Yes. Now, once if you have thrown the bones, you see whenever you are sitting at some dhaba, You are going to throw the bones. Doggy is there. And those bones which you are going to throw, the doggy is going to have it. And they are enjoying it. Have you ever seen? Have you ever seen the doggies? They are going to enjoy those bones. The crow that is going to enjoy those bones, or the eagle is going to take those bones and it will throw the bones from the above and they will eat it. They will enjoy it. So kids, the crocodile is going to swallow you as a whole because they enjoy it. Now see kids, this reaction, this NH2 negative is saying, I'm a very, very strong base. I am a very, very strong base. I'm a very, very strong base. And with respect to me, the hydrogen which is not acidic, I'm liking this hydrogen. For me, this hydrogen is acidic. Then everyone started saying, what's the problem with these hydrogens? Why you're liking ortho hydrogen only? He's saying, I will let you know. Let me take this hydrogen, then I will let you know why I'm liking ortho hydrogen only. See kids, why I'm liking ortho hydrogen only. Just see to it kids. This has taken this proton, so it will develop negative charge. Here is negative charge kids, and this is halogen. Now you see, this halogen is going to stabilize this negative charge because this is applying minus I, this is applying minus I, that is electron withdrawing group. So what do you think? Inductive effect is distance dependent or distance independent? Kids, do let me know. This inductive effect is a distance dependent factor or distance independent? Definitely distance dependent. So minus I would be more applicable when the distance is less. Where is least distance? At ortho, meta or para? Where is inductive effect is maximum applicable? Minus I or plus I is at ortho, then at meta, then at para. This thing I have told you or not, kids? Do let me know. This thing I have told you or not? Yes. So that's why these ortho hydrogens are looking acidic to it. Now see kids, mind-blowing thing is going to happen. See, just stay tuned. Everyone see to it. This X, this was showing resonance with the benzene. That's why this bond was powerful. As the lone pair of X was doing resonance with the benzene, but once the benzene has got negatively charged, benzene is saying, hey X, don't send your electrons to the benzene. I can't afford. Even I have become more electronegative. So just take my electrons. So there is electronic repulsion in between this. Electronic repulsion. Now kids, due to electronic repulsion, its resonance got stopped. Now this lone pair is not able to do resonance with the benzene and they have become localized. Now Na plus will come and will say, hey halide, what do you say? Do you want to come along with me? Yeah, X said, take me away. And this has gone, and the positive negative charge, one more bond has been formed. See how it will look like. Now benzene will look like this. See kids, how it will look like. Just try to understand. It will look like this with extra one bond. Can you see? Have you ever seen this structure? This is not benzene. Because of this extra pi bond, this is known as benzene. Benzene, kids, it is known as benzene. Now, what do you think? What should be the hybridization of this benzene? What do you think? Is it aromatic or unaromatic, non-aromatic, anti-aromatic? What will you say, kids? What will you say about benzene? Let me tell you, benzene. What is your idea about the benzene? If you are thinking, if you are getting this structure for the first time, do let me know. Is it aromatic or not? Is this benzene aromatic or not? What's your idea? This is the first time you are going to see benzene. This is your benzene. Benzene. What will you say? According to you, is benzene aromatic or not? Just to let me know, everyone. I'm waiting for your answer. Is your benzene aromatic or not? Non-aromatic. See kids, this is aromatic. First answer is wrong. You said non-aromatic. It is aromatic. See why it is being aromatic. I'm going to tell you first thing, first answer, why it is being aromatic. Kids, when I taught you aromaticity, I have told you one thing, that Huckel said consider only those pi electrons which are delocalized. So when you are going to consider only those pi electrons which we are having delocalized pi electrons, then they are only 6. These 2 pi electrons are not taking part in delocalization. So out of 8 pi electron, only 6 are delocalized. Only how many are delocalized, kids? Do let me know. Out of 8 pi electrons, only 6 pi electrons are being delocalized, right? That means the number of delocalized pi electrons, they are following Huckel's rule, and this is planar because this is planar also, and it is following Huckel's rule also. So this is aromatic. Now you must have studied that aromatic compounds are highly stable. Never say that aromatic compounds are highly stable. Yes, generally aromatic compounds are highly stable, but not always. This is being aromatic, but then also it is highly unstable. I would like to say aromatic, then also it is highly unstable. Who is making it to be unstable? That extra pi bond. Now kids, if I ask what is the hybridization of this carbon, let me say this yellow carbons, what is the hybridization? It is attached with 2 pi bonds. Do let me know, everyone. What is the hybridization? Do let me know. I'm asking about hybridization of this triple bonded carbon. Yes, kids. Definitely your answer will be SP. Everyone is writing SP. So kids, don't write in the examination SP. Your examiner will give you 0 marks. It's not SP. It is SP2. Now you will say, sir, what is this? We have to study it. Whenever in between 2 carbons there are 2 pi bonds, they are supposed to be SP. Let me tell you, you must have studied this acetylene or triple bonded carbon. This is SP. Okay. Then you must have studied one thing more, that it is linear in shape. Linear. What do you think? If you're going to draw it to be SP, is it possible that this is going to be linear? Can't be linear. It can't be linear, and can't be linear. So can't be SP. Kids, number of questions have been asked in the past years. They had asked number of questions on the basis of this concept. Let me tell you, this benzene is going to play, and it holds a whole lot of weightage. Kids, we have to understand each and everything. Are you enjoying it? Now see kids, this pi electron is very, very big bond. How to draw its structure? Let me tell you how to draw its molecular orbital theory. If you want to see the molecular orbital theory of this pi bond, let me tell you. The benzene is like this. These pi bonds are overlapped, they are forming good bonding, but the extra pi bond, you will see it's like this. See, it is moving like this. This question also has been asked, that's why I'm telling you it's like this. Now you see, its direction is towards this. This is boundary surface diagram, not the orbital, boundary surface diagram. Now the pi electrons are moving like this. Now moving like this. See, just try to understand. If I'm going to draw it properly, the pi bonds are moving like this, moving like this, moving like this, moving like this, and its pi electrons are moving like this, 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 and its pi electrons are moving like this, moving. See the overlapping, very, very poor overlapping. If anyone is going to form pi bond, the pi bond should be like this. See, this is better overlapping of pi bonds. If they are parallel like this, this is boundary surface diagram, this is boundary surface diagram, and if I extend it, the overlapping is like this. The overlapping would be like this. The overlapping is like this. This is handsome overlapping, good overlapping. So the pi bond is okay. This is the pi bond formation, pi bond formation. But here you can see the bond angle, they are not parallel to each other. They are not parallel, and parallel, they are not parallel, then how the pi bond is good? They are not parallel. So very, very poor overlapping in benzene. There is very, very poor overlapping in benzene. Very, very poor overlapping. And because of this very, very poor overlapping in benzene, this extra bonding is not effective bonding. This is very, very poor overlapping, very, very weak bond, very, very weak bond. And that's why we will not consider it two-way bond. We will say it is sp2 hybridized only, because we are not going to consider that bond. This bond is not effective bond, not effective bond. And if this bonding is not effective, then the extra electrons, they are free. Then the extra electron, they are free. Now see the second, that's why the second step of this benzene mechanism. Now see the second step. I hope that everyone is able to understand benzene. Do let me know. Show me the thumbs up if you are enjoying it, if you're liking it, if you are understanding it. The second step of this benzene structure, each and everything I've told you, the chemical bonding I've told you, each and everything. The second step. Second step is addition. Second step is addition. Just 10 minutes more, kids. So this is your benzene. And this is your extra bond. Now once again, NaNH2 will come. NaNH2 will come in liquid ammonia. That reaction takes place in NaNH2 negative and liquid ammonia. Why liquid ammonia? Because once this NH2 has taken the proton, you see that reaction, that step, that NH2 has taken the proton, then definitely it is going to form ammonia. Where it has gone? I have shown you that first step, this NH2 negative has taken proton, so it must have formed ammonia. So ammonia is there. So see, once NaNH2 is there, ammonia is there, what is going to happen, kids? What is going to happen? See, this benzene, this pi electron can move either in this direction or it can go in this direction. A little bit less speed I am going to tell you. This pi bond can shift toward this carbon or it can shift toward this carbon because there is symmetry. Is it okay? It can go either towards clockwise or anti-clockwise. That means two possibilities are there. See, what are these two possibilities? These two possibilities are there. It can look like It can look like either like this negative charge, positive charge. It is coming over here, negative, positive. Positive, negative. Two possibilities are there, kids, right? Now see, from which carbon halogen has eliminated out? This was this carbon only. So if I talk about NH2 negative H positive in this compound, NH2 negative will come and join to this carbon from where the halogen has left, and H plus will come and join this carbon, then you will get normal product. But if NH2 negative is going to come and join this carbon, and this was the position where halide has left, then this is going to form abnormal product, because both are being formed in same amount. So equimolar product will be formed. The normal product, this is going to form normal product, this is going to form abnormal product. See how this will form this product, this will form this product. See what are these two? It will give you this normal product. Why normal? Because from this position only halide has left. And this is going to give you abnormal product because it is ortho, and they are formed in 50-50. 50% this and 50% this. So this is abnormal product and this is being normal product. Kids, I hope you are able to understand, and this was the reason why normal and abnormal products are formed in equal amount. Now see, I'm going to give you one question that is top rank deciding. Yes, see kids, always remember that, before giving you question, I'm going to tell you one point. What is that point? That point I'm going to tell you, very, very important point, very, very important point. See kids, in case of halobenzene, very, very important point. No teacher is going to let you know this point. There is your HSP Baba only who is going to tell you. Very, very important. In case of halobenzene, two types of mechanism is always followed. Two types of mechanism is always followed. What are these two types of mechanism, kids? Let me tell you. One is addition elimination, through carbanion formation, and second one is elimination addition. Through benzene mechanism. It's both are nucleophilic substitution, whether I talk about this reaction or I talk about that reaction, both are being nucleophilic substitution ArSN2 reaction. Both are ArSN2 reactions. So whenever the question is coming like this, see kids, if you have this knowledge, no question will get wrong. See kids, if this is brilliant question was asked by the examiner, just see the question was like this. Question was like this. Find out the intermediate. Find out the intermediate formed during this reaction. Formed during the following reaction. The reaction was like this. Halogen was given over there. They have given NaOH or NaNH2, and it was given like this. And the options are, A option is being carbocation, B option was carbanion, C option was benzene, D option was both B and C. Kids, what should be your answer? Do let me know. What should be your answer? I'm waiting for your answer, kids. If you are able to understand, do let me know in the chat section that what should be your answer, kids. Yes, everyone. Do let me know what answer you are going to get. I'm waiting for your answer, kids. Hey, everyone, do let me know. Ammonia. No, ammonia, no. These are the four options. These are the four options. NaNH2. These are the four options. Out of these four options, you have to say what is your answer. So, kids, you're not able to answer it. Let me tell you, your answer should be both B and C, because whenever halobenzene is provided, it will always follow both the mechanism, that is carbanion as well as benzene. And this is the, wow, your answer I got, D. Fantastic, fantastic, kids. Really, you are the best students. Now, I'm going to tell you the question, exact that question which has been asked in 2016 NEET. Are you ready? Exact question of 2016 NEET. Same question which has been asked 2016 NEET. The question was given like this, and this was really fantastic question. Here OCH3, here X, and they have given NaNH2 liquid ammonia. And they asked about major product kits. Even they have given the answer and they asked the mechanism, but here I'm going to give you the options, and do let me know what answer will be the major product. This is the last reaction for today, kids. So this is really, it is going to require too much time. Let me check it out whether you are going to give the correct answer or wrong answer. X, let me write down here NH2, B, OCH3, this is also ortho, let me write down here NH2, C, OCH3, from where it is gone, let me write down here NH2, D, none of these. This is a really brilliant question, and let me check it out who is going to give the correct answer of this question. This is marvelous question. And the one who is going to give the correct answer, really, if your explanation is fantastic, then I will say yes. We will feel accomplished. Okay, the ball is in your court right now. Let me check it out. What answer you are going to give? Maximum students are going for C. It's so fast answer is given by you. Would you like to see the mechanism? I don't know what is the answer. I'm not going to reveal it right now. We will follow the mechanism, we will follow the path, and then we can check it out. What is the correct answer? Kids, do let me know. Are you interested in the mechanism? How to do this? Do let me know. Why only one product? Question arises, why only one product? Although this is going to follow benzene mechanism, and benzene mechanism said that two types of products, equal amount, they are going to get formed. And why you are asking only for one product? That is the question. Now see kids, how to do this reaction. This is really very important reaction. This is your reactant or the substrate OCH3, and this is halogen. Now from this halogen, two possibilities are there. Either this hydrogen will eliminate out or this hydrogen will eliminate out. Either this hydrogen or that hydrogen. Let's eliminate out both the two hydrogens and try to find out what thing we are going to get. If I eliminate out the upper one, then the negative charge will develop over here, OCH3, and this is halogen. And if I remove this proton, then the negative charge will develop over here, hit this position X. Kids, let me say, rename it. This is X carbocation, this is Y carbocation. What do you think? Which? No, sorry, carbocation, carbanion. This is X carbanion, this is Y carbanion. What do you think? Which carbanion is being more stable? We will go through the points, we will go through the mechanism. What do you think? X carbanion is more stable or Y carbanion is more stable? Do let me know. Because organic chemistry is not the cramming thing, it is just mathematical. Which carbanion is being more stable? Do let me know, everyone. What do you think? Which carbanion is being more stable? Everyone, I will go according to you people only. Second one is more stable. Okay, let me check it out. Why? So everyone is saying Y is more stable. Kids, your answer is wrong. This is being more stable. Now ask me why. Today, see, your answers are getting wrong. Just ask me why it is like this. See kids, X is common to both. X is common to both. It's X is common, so its minus I is also common. Okay kids, minus I is also common. Now who is not common? OCH3 is not common. This is also putting minus I. So from where minus I is more effective, at ortho or at para, this OCH3 is going to put minus I, and it will require too much distance, and here it is just present at this. So X is more stable. So this route is right and this route is wrong, because its activation energy will be very high. EA will be very high. Are you getting my point? So this is not followed and this activation energy is low. This is followed. Everyone is able to understand. So methoxy group, alkoxy group is going to decide which carbanion is being more stable, right or not? So carbanion stability is decided by carbanion stability is decided by alkoxy group, OR group, alkoxy group. Am I right? So this is being more stable. Now let's take it out. Let's take it out. If this is being more stable, so halide will go from there. This is being more stable. So definitely the halide will go from here and it will take electron, the positive and positive negative, which charge will develop, the benzene will be formed. So this benzene is formed, kids. This is your benzene in between this. So definitely this benzene is formed. Till now this is elimination reaction and we have reached to the benzene. Everyone clear? Is everyone clear till now? This benzene will get formed. Do let me know. Now let's take this benzene on another page. So this was your benzene which was formed. This was your benzene which was formed. Now in this benzene, the pi bond can move. This pi bond can move. This pi bond can move either towards that direction or towards this direction. Both the two possibilities are there in the mechanism I have told you. Now two types of compounds will get formed. See, if it is going to move towards this direction, there will be negative charge. And who is going to attack over here? The positive. NH2 is going to attack, or the proton is going to attack, right? And if it is going to shift toward this side, what will be the condition? OCH3. Here will be the positive negative and the negative positive, right? These are the two possibilities, kids. Right? Now see, if I say the proton has attacked over there, then the plus charge is over here. Or the NH2 negative has attacked over here. At this condition, NH2 is attacking, and in this condition, NH2 is attacking over here. This is bulky group, which will feel more steric hindrance. This bulky group is going to attack where it will feel more steric hindrance, in the case M or in the case N. What do you think? In which case bulky group will feel more steric hindrance? Do let me know. In which case bulky group is going to feel more steric hindrance? See, here it is near to this OCS3, will feel more steric hindrance, will feel more steric hindrance, right? And there it is going to feel less steric hindrance, less steric hindrance, right? Now this is the hindrance factor. There is one more factor which is going to give you clear-cut idea. See, when this is going to attack over here, the carbon ion is too far away from this OCS3, but if it is going to attack from here, this carbon ion is too nearest to this, so this will be followed, this will not be followed. So definitely whatever the answer given by you is absolutely correct. Only one type of product in this reaction is going to form, that is this. This is the super awesome thing. Note the second product will form. Only this is your product. Only this is product. The second product will not be there, kids. This is the product, and absolutely correct, kids. So congratulations to all of you. That I don't think that you have gone through this much of mechanism. By chance, you have given the answer and that answer is found to be correct, absolutely correct, kids. But just to let me know in the chat section, have you thought like this? Was your thought process like this? Have you gone through this much of mechanism before giving the answer, or by chance your answer has been found to be correct, kids? So likes are 56. I would like to say before ending this session, likes should be 60, at least 60, kids. At least 60 likes should be there. And how to revise these things, let me tell you. When you wake up in the morning, first thing, always say to yourself, you are an important person. If you think you are able to do anything, you definitely are going to do that. And if you think you are an important person, you will do each and everything like an important person, and definitely one day you are going to become an important person. And this is old saying, where there is a will, there is a way, but still true. Once you think you are able, all the obstacles in your path will disappear and the means to its achievement will appear in front of you. This is the thing. We know that nobody is born with silver spoon in one's mouth. We can do, we can achieve with our hard work, and the one who is doing hard work, success is waiting for all those kids. Kids, do let me know, are you able to understand what I'm saying? And in the starting, Buddha Surya said, sir, this is not fair, that we also need mind map. How many of you need mind map of organic chemistry, mind map of inorganic chemistry? Because there is one session, mind map by HSP, that is another session, and the fees for that is 2,999. But right now there is offer, huge discount is going on, and kids, it's available only for 1,999. You won't be able to believe that on the very first day, 100 seats have been filled. So this is the power of mind map. But I'm not saying that if you're not able to buy for 1,999, then also you have to be regular. You have to show your perseverance, persistence, permanency. I will give you memory chart, mind map here also. So kids, do let me know, so that I should not waste even a single minute. Recorded memory chart I will put for inorganic chemistry and one for organic chemistry. So you should be able to understand that how memory mind map looks like and how much it is going to give benefit. So such type of 15 mind maps I'm going to give in that course. That is the course available everywhere, you can see. And this session is going to get started from 3rd of September. So kids, bye to all of you. We'll see you in the next session, and do let me know in the comment section that how many of you need mind map over here also. Then I will put one recorded video of 10 minutes. I will put the memory map on the board, and then I will explain it so that you can save your time, because time is very, very precious. Bye kids. This is your HSP Baba, 23 plus years of experience, and Tanishka Yadav, the first rank holder. I have told you she got first rank because of addition of this mind maps. Whatever the knowledge she was having, other students were having even better knowledge than that. We cannot compare, but yes, they were getting more marks, but she got best rank because the contribution of mind map, HSP Baba's mind map was there. Bye to all of you. We'll meet you soon. May God bless you kids.